Okay everyone, today we have a 2005 Ford Escape 2.3 liter that you may remember from a previous video. I actually had two videos on it, a two-part series. It's the lightning strike vehicle. It had a lot of different problems with the PCM, the cluster, just about everything was wrong with the vehicle due to the lightning strike. And that's common when a lightning strike occurs. The sensitive sensors on the vehicle can go out, and of course the modules are all suspect to having issues after a lightning strike, direct or indirect. And this one was indirect, but it did enough damage. So if you don't remember from the last video, what I figured out is the fuel rail pressure sensor was totally skewed, 30 psi off, no problem, and it caused the vehicle to run extra rich, and therefore the vehicle died out and it barely ran at all. So with that disconnected, it goes into a failure management effects mode, and I was able to drive it, bring it back to the shop here, and we're going to finish the diagnosis on it. So we have to diagnose that. We got to diagnose an ABS module that's not responding. The high-speed CAN network is down, and the alternator is overcharging at 19 volts. So we're going to delve into all of those things with the schematics and all my tools I have here, and we're going to finish walking through the diagnosis, and then we're also, of course, going to do videos after this on all the repairs we're going to make on here. So let's get to it. Okay, so the first thing we're going to go after is the fuel rail pressure sensor, and the reason being is we're going to have to pull it off of there and do fuel pressure test and take it off and make sure that the PCM does or does not read zero when it has zero pressure, to make sure it really is skewed and it isn't one of the lines that are actually melted together on there. So we want to do that on a cold engine. So we're going to start with that first and take care of that, and then we'll move on to stuff like the alternator where the engine has to be running. Okay, so down in here, it's very easy to get to. It usually is on these, is the fuel rail pressure sensor right here. And this gives the reading back to the PCM so that we can give a duty cycle out to the fuel pump, so it only provides enough pressure through this line to drive the injectors properly. So it's relying on an accurate pressure reading down in here to drive that driver module back there in the fuel pump, because there is no return on here. There's no return. It's the returnless electronic fuel system, so it has to be accurate and has to be correct. Okay, now in order to see if this sensor right here is biased, what you can do is make sure there's no pressure in the fuel rail, and then you can go ahead in the scan tool and see what kind of pressure that it's actually reading. Obviously it should be at zero, so if it's anything but, we know that it's biased. So in order to do that, what we're going to do is plug it back in, so we get a reading, and of course we made sure that the pins on here were not corroded or wires melted, anything weird like that. So the whole harness is intact. And then we're going to make sure this fuel rail right here is empty, 0 psi, so we get an accurate reading of what should be in there. And in order to do that, we're going to come over here to the fuel line, disconnect it. Now this is a cold engine, there should be no fuel pressure here, so we're going to have minimal spillage. It's always a good idea to make sure your engine is totally cold whenever you pull a fuel line off. And then we're going to disconnect it back over there where it goes down to the fuel tank. We're going to cap it off, and then we're going to turn the key on to pressurize the fuel system, and of course we'll wake the PCM up so we can monitor the fuel rail pressure sensor live, and I'll show you that. Okay, so let's get this vacuum line out of the way. We'll release the lock on it, pull it out of the way. Now these fuel lines, they have a lock on them and a secondary lock down below. You just need to pick it loose and pull it out of the way, and this whole lock comes up on here. So just be careful. You want to release it. It's a little bit of a pain, but you don't want to twist this line and start flexing it, because this whole thing's plastic. It's gone through a lot of heat cycles, and it might crack on you. You don't want that happening. Put a stress fracture in it type deal, and then it goes down the road and cracks and sprays fuel everywhere in a hot engine. Once it's free, the secondary lock on there, you just need to kind of push it through like that. You'll see it like that. And then we'll make sure we have rags around it. And you can slide it off like so, catch any fuel spillage. Okay, and then we're going to follow this line over to the metal tube that comes from the fuel tank, which is right here. And there's another lock on there. It doesn't have a secondary latch on, so you pull that off, pull it out like that. And we can slide that one off too. Okay, that one's leaking a little bit more. And we can pull this whole line out of here. Okay, so I'm gonna put a fuel test fitting on here. Make sure it's nice and tight so it doesn't blow off. We're not gonna start the engine or anything, but still. It's gonna have pressure once we pressurize it on here. We'll clamp it off. Then, at the end of this, we'll be able to connect an ordinary fuel pressure gauge to it. And that'll cap the line, and we'll also be able to get an accurate pressure reading also. See what the true system pressure is. Okay, have the scan tool out. We're going to check the fuel rail pressure PID. We have it connected back up. We've got 0 fuel pressure. We can see that. We got our line capped off over there, leak free. To our fuel pressure gauge, we have about 30 psi, 29, 28. So we have pressure in the system, but there's to be no pressure in this fuel rail. We can see the end of it's taken off here. All right, so let's go in here and look at the fuel rail pressure voltage, the pressure it's reading, desired temperature, and the voltage for the temperature on there. And let's see what we're reading. Now, remember, there's no pressure in the fuel rail right now. Should be at 0 psi. And you can see right here, it's telling the PCM, hey, we got 39 psi of fuel in that fuel rail line, 39 psi of pressure. We're at 0, so you can see how the reading can be way off, and that's way freaking off. Now, the fuel rail pressure voltage is about right for that pressure reading, so that's why it never throws a fault code for it, saying the sensor is either damaged or whatever else. It's reading something. It's not totally off the charts on the outer limits of 0 and past 5 volts. Now, this is just the pressure desired for startup. That's fine. Fuel rail temperature, that's reading correctly, 65 volts, and the voltage down here is also correct. So that means probably our VREF coming from a PCM is just fine. What we need to make sure of is the signal getting back to the PCM is just fine. So let's start doing some pinpoint tests and see what's going on here. See if it's a harness, the PCM, which shouldn't be because it was changed by the customer, and or the fuel rail pressure sensor, which I think it is. Okay, so the next thing we're going to do is we're going to test the circuits coming into the fuel rail pressure sensor, make sure it has a proper ground and voltage so it can work properly. And then after that, we're going to test to make sure that the signal is getting back to the PCM itself. So the first thing we're going to do is we're going to make sure it has VREF, which is pin 2 right here, and it's 5 volts. That is produced by the PCM, so it's regulated by the PCM to 5 volts. And then over here is a reference ground, also coming from the PCM, so we know both of these are good and the sensor can work properly. So let's go for the VREF first, which should be 5 volts. So the other end of the meter, I have it on the negative of the battery. So we're going to have 5 volts now. Now the next thing I want to do is I want to test that ground on there to make sure it's getting that reference ground. And all this is required for these sensors to work properly. So let's go over here and put on the positive into the reference, and we have our reference ground and reference voltage coming into it. So it should work properly as long as we can get the signal back out through the harness to the PCM. So what we're going to do is we're going to concentrate on pin 1, and that's the fuel rail pressure reading going back to the PCM. So the way we're going to test this harness is very easy on here actually. We're going to take these pins we know are already good, the VREF and the reference ground, and we're going to send them through there back to the PCM and induce a low voltage and a high voltage and make sure the scan tool over here responds, and that's what the PCM is actually seeing. So that tests the whole harness and the PCM all at once. It's a very simple test, and then I'll tell you right there if we need to dig further into the harness or not. Okay, so pin 1 right here is the fuel rail pressure reading going back to the PCM. So the first thing we're going to do is we're going to induce a high voltage, which is the max voltage, which is 5 volts, back to it. And the scan tool is still seeing 5 volts, so we're good there. Now the next thing we're going to do is we're going to give it a reference ground, and I'll show you how that looks on there when I do that. So let's put you over here onto the scan tool so you can see what I'm talking about here. And up top there is the pressure, it's calculating, and then down below is the voltage. And those should correlate also. So here we go. We're going to induce a ground back to there, which should go to 0 psi, and of course 0 voltage. And it responds, no problems. And whenever you're doing this, you're basically sending a signal back to the PCM. So either high or low voltage you're inducing to it. What you can do is you can start, everything's good, okay, we're sending that back, we're basically sending a signal out. What you can do is start shaking the harness and moving stuff around and doing the wiggle test on here to see if there's any problems with the harness going back, if there's any glitches that are going to show up on the scan tool here. Now I already did that and everything looks just fine on here. So at this point we know the fuel rail pressure sensor, it just got fried when that lightning strike hit. So we definitely need to change that out and retest from there. Okay, voila, through the magic of film, our sensor is changed out, all back together. Our fuel rail is still apart as far as fuel pressure in there, so we should have 0 psi. Now let's see what the PCM actually reads on here, when it's getting back to the PCM. So we got 0 psi, so it's not biased anymore, 34 psi, 39 psi before, and our fuel rail pressure voltage is reading correctly also. So at this point, once the vehicle starts, we should have a proper fuel reading so that it can accommodate and adjust the fuel trims correctly based off of this information on here. So I'm going to go ahead and start putting the rest of the system together on here, the fuel line and stuff like that, make sure it's all snapped back in, and then we're going to go ahead and start it, and we're going to check the fuel pressure reading on the scan tool also, and do an injector drop test, stuff like that. Now as one final check on here, I'll do a fuel system pressure test with the scan tool, which will make sure we can read the pressure increase and decrease. So to go through a whole series of tests on here. First thing it's going to do is pressurize it, make sure it can read fuel pressure, and then it's going to make sure there's no large drops in the system so it can safely go on from there. Now it's going to drop a couple PSI, no big deal, and then it's going to kind of stabilize there and it'll let it go on from there. After that, it's going to go on to the injectors themselves, and we'll test each one of the injectors to see what kind of flow they have. And the way it does this is that it pressurizes the systems to a pressurized value, a known value that lets it stabilize, and then opens the injector and sees how long it takes to drop a specified amount of fuel pressure, and that's how it gets its millisecond reading for each one of them. It'll show down here. Okay, let's go in and check some of the PIDs having to do with the fuel rail system. Voltage desired, pressure, fault, temp, and temp voltage. And I already pressurized the fuel system a couple times, a couple of key cycles. So let's go ahead and start it, and we should be able to see. Reading nicely. So that's a good fix on there. And now the vehicle's going to run properly so we can do other testing on here. Okay, so the vehicle starts and it runs absolutely perfect, so our drivability concerns are definitely gone. At this point, we need to concentrate on the alternator. It's charging at 18-19 volts, and that's definitely not good for any of the sensitive electronics on the vehicle. So we're going to go ahead and change that out. I'll have a separate video on that. And I also made a separate video on changing out the fuel rail pressure sensor because it applies, the procedure applies to many other models and years in the Ford vehicle lineup. The next thing we need to go after is the ABS module. It's not responding at all, and we need that for ABS, 4x4, odometer, and speedometer on this vehicle. So we need to get that up and running. Also, part of the high-speed CAN network is not functioning properly, so depending on which module you have connected, it takes down part of the network or all of it. The other thing we have, the icing on the cake, is a battery draw. So we got to figure out why that's happening, because that's becoming a real pain, taking off the negative each night and dealing with that. So stick around for part 4. We're going to finish diagnosis on this vehicle, and then of course the repair videos will come out afterwards.